Hello everyone. Are you familiar with crystals? Maybe you are familiar with the stereotype that crystals are sparkly and beautiful solids. In chemistry, a crystal is a material composed of atoms, ions, or molecules arranged in a highly ordered repeating pattern that extends into all three spatial dimensions. The regular arrangement of these constituents forms a lattice of crystals, which gives the crystal its distinct structure and physical characteristics. In this video, the crystal solid that is going to be thoroughly analyzed is called cadmium iodide.
Cadmium iodide is an inorganic compound with the formula CdI2. It is a white hygroscopic solid. It is notable for its crystal structure, which is typical for compounds of the form MS2 with strong polarization effects. Cadmium iodide crystallizes in a hexagonal unit cell. In this structure, the iodide ions form a hexagonal close-packed lattice, and the cadmium ions occupy every octahedral hole between these layers. To explain this behavior, iodide ions are relatively large compared to cadmium ions. Their larger size makes it efficient for them to form a hexagonal close-packed HCP lattice, which is a dense packing arrangement. The HCP arrangement allows iodide ions to pack closely together, optimizing space and minimizing repulsion between the large negatively charged ions. This packing results in a stable and dense lattice structure. Cadmium ions are relatively small and have a +2 charge. The smaller size and higher charge density allow them to fit well into the octahedral formed by the larger iodide ions in the hexagonal close-packed structure. As for the unit formula, we will be calculating the number of iodide ion and cadmium ion in a single unit cell. From the 1/3 of the hexagonal unit cell, there are 8 iodide ions at the 8 corners, and 1 iodide ion at the center of the cell. As for cadmium ion, there are 1 ion that occupies the octahedral hole of iodide ion. After summing up, the number of iodide ion and cadmium ion are 2 and 1, respectively, giving the unit formula of cadmium ion is 1.
From this large, continuous repeating unit of the hexagonal cell of the cadmium iodide compound, we can zoom in into one unit cell. It also represents the full symmetry of its crystal structure. As we can see from this 1/3 portion of the hexagonal cell, all of the corners of the rhombus area are occupied by iodide ions both at the top and bottom sides. Additional to that, there is one more iodide ion residing at the center of this unit cell, specifically at the coordinate of 2/3, 1/3, 1/2. As for the cadmium ions, there is only one located at the center of this unit cell. The coordinate is 1/3, 2/3, 3/4. This location of cadmium ion is also known as the octahedral hole of the hexagonal closely packed arrangement. For your information, there are actually 2 octahedral holes in total in one hexagonal unit cell. Another one has the coordinate of 1/3, 2/3, 1/4. However, for the case of cadmium iodide crystal solid, only half of them will be occupied by the cadmium ion. According to earlier analysis, the structure of cadmium iodide is layered, with iodide ions forming a hexagonal closely packed lattice and cadmium ions occupying the octahedral spaces between these layers in the alternating sequence. This results in a coordination number of 3 for iodide ions and 6 for cadmium ions. In a crystal, the number of atoms or ions that are directly attached to an element is its coordination number. sometimes referred to as the number of nearest neighboring atoms or ions surrounding the central element. Since the surrounding cadmium ion in this ionic solid is composed of 6 iodide ions, the cadmium ion in the octahedral holes will have a coordination number of 6. However, for iodide ions, the coordination number is not the same. When we closely examine the crystal structure of this compound, we can observe that one iodide ion is only surrounded by 3 cadmium ions due to the alternating layers of octahedral holes filled by cadmium ions in the hexagonal closely packed array of iodide. As a result, the ratio of the coordination number of cadmium ions to iodide ions will be 6:3.
Cadmium iodide has several important applications due to several factors related to its crystal structure and chemical properties. It is used in electroplating, where it is a process of using electrodeposition to coat an object with a layer of metals. CDI2 has a layered crystal structure, where cadmium ions are positioned between layers of iodide ions. This structure allows CDI2 to dissociate easily in aqueous solutions, releasing CD2 ions that are essential for the electroplating process. Cadmium iodide is also a common component in the manufacture of phosphorus. Phosphorus is a material that emits light or luminescence when exposed to radiation such as ultraviolet light or an electron beam. Cadmium iodide can be combined with various host materials to create different types of phosphorus with tailored emission properties. For example, the use of cadmium iodide allows for precise doping with other elements, such as rare earth ions, to fine-tune the emission characteristics of the phosphor. This is crucial for developing phosphors that emit specific colors or wavelengths of light. Finally, cadmium iodide is also used in the manufacture of electronics devices, including photovoltaic cells and light. Cadmium iodide can exhibit semiconductor properties due to its crystal lattice characteristics and electronic structure. In semiconductors, electrical conductivity is due to the movement of charge carriers, which can be electrons, which is negative charge carriers, or holes, which is positive charge carriers. When cadmium iodide absorbs energy such as from light or heat, electrons can be excited from the valence band to the conduction band, creating electron-hole pairs that contribute to electrical conductivity.